Hello YouTube, RJ. We're going to learn an important lesson in this video about new parts. But first, I want to thank all my subscribers for taking the time to click subscribe and help me on the journey of growing this channel. With your help, we're over 700 subscribers and working towards the 1,000 subscriber goal. In the last video of the series, we took a look at my home built antenna tuner and the issue I had with it whenever I bypassed the tuner to pass the input directly to the output. I hypothesized that passing the RF to the front of the unit to a switch and running the RF back to the rear was adding a mismatch on the SWR, so I designed a relay-based switchboard that would mount next to the antenna ports. This should, in theory, solve the problem. If you haven't watched that video yet, and you want to before you watch this one, I'll put a link on the screen for the part 1 video. Let's jump on the bench, assemble, install, and test this solution to see if it solved our problem. Before we can jump on the bench and assemble this thing, we've got to design the PCB and get it off and get it made. I don't want to make you watch the whole thing drag out 30 minutes doing a circuit board design, so I'm just going to do a sped up version. We'll drop back in and show you the final design before we go to assembling it. Okay, and with imaginative editing, our PCBs from PCBWay are here, and it's time to assemble them. So of course we've got our two diodes, and of course these diodes are just to allow the back EMF from the coils when you disengage a relay to have a path back through the relay coil so you don't get high voltage spikes. So I'm going to go ahead and put these through and get them soldered. We'll move on from there. Okay, I'm just making sure I get these diodes put down tight against the board. I'm going to go ahead and clip off some of the longer part of the lead because it sucks the heat from the soldering iron away. Makes it easier to get in there close and get the soldering iron and to heat up quickly. You'll notice I'm using the new HS01 soldering iron that I reviewed recently. Thought I'd give it a run. I'm liking it so far. It works pretty well. I run it at 360 degrees C, and it seems to do very well at that. if you're very astute in watching the video, you might catch that sometimes I forget to push the pedal for the fume extractor. Shame on me, but I'm getting better. It takes time to get used to new equipment like that and being able to remember to do it. It's sure better than breathing all these toxic fumes. The lead, people think they're vaporizing lead. That's not a problem. It's the flux that's an issue. So we've got our relays, and looks like they pop in right in the board as I had hoped. It's always nice when you can download the pattern from your supplier, because when you have to go in and actually look at them, and got a few pins just a little off here, but when you have to go in and actually do the pattern yourself, you're always possible to make a little error, and then you can't get the device into your boards. But so anytime you can find a footprint and download it for your CAD software, it's the way to go. Not much to this board, as you can see. Just a couple diodes and 3 relays. And you see that I've got my modified tip cleaner up there that in a previous video I built. Works very, very well. You can see my well-used tip cleaning can there, 10. It's been through a few tip cleanings, as you can tell. I'll go ahead and finish these up, and I'll come back in just a minute. And with that, we've got our board finished, ready to put it back in the antenna tuner, actually mount it up, get it mounted, and then wire everything up. And we'll be able to find out, have we successfully improved the antenna tuner? So stay tuned. We're going to get on the bench and get this thing mounted. I'll come back when I've got it mounted up, and we'll wire it up and we'll do some testing. Hey, I just want to add a little something here. There's a lot of talk about, oh, you get things from China and, the stuff's no good, and, you need to buy things from Mauser, DigiKey, get quality, non-fakes. But I just want to point out that's not necessarily not true, but at the same time, even when you buy things through places like Mauser and stuff where you're getting, you're not getting fakes, you still get bad products. And I'm going to give you a perfect example. I just put this board together. You probably saw, I imagine I probably did a time lapse of that for you. And I put the 3 relays. Now these are relays I bought from Mauser, brand new. Luckily I ordered 5 instead of 3. Wanted 2 of them to put in my parts bin to have for some project comes along. I need a relay instead of having to wait on getting it, paying shipping. I got it. So I went ahead and got 5, and it's a good thing because I got it together. I took my meter, started doing a sanity check to make sure that what I was expecting to be where was, and everything was great until I got to the antenna relay to where it switches which antenna, and I wasn't getting anything on either one. So I thought, oh man, you've made a mistake in the design of the board. So I started checking, and I got to the relay. The relay, everything was good right up to this relay. Okay, here's my coil to energize the relay. Here's my contacts. The center pin is your switching contact. Your 2 outers are your normally open, normally close. Now in this case, this is your normally close. I should have no resistance there pretty much. And yet you can see my continuity meter is working just fine. I've got nothing there. Okay, well maybe I've messed up. Maybe it's normally closed this way. No. These pins each interconnect. So this pin and this pin is the same as this pin and this pin. This relay has no connectivity at all in any direction. And therefore, it's bad. So I had to remove it, pull one of my 2 spare out and put in. And I'll show you. Let me flip her over here. This is the one I replaced it with. If you go to those same 2 pins, get on there. You go over here. All right. Here's this one. Same 2 pins. Nothing. You know, just remember, even name brand from a reliable source, you can't be 100% sure that your part's going to be good. So, not a common thing, but does happen. So anyway, just thought I'd throw that in there for you. I've got the new board installed. Sorry about the fan noise from the power supply, but I needed the 12 volts on the bench to run the solenoids or the relays on the board. Here it is back together. Nothing new with the tuner, other than you can see that we've installed our board here, and we have it all cabled up. We've got it cabled through the the automatic tuner circuitry here. We've got our input over here coming into the board here, and then if you're on the tuner, it comes right back out and through the tuner and returns back to the board over here, routed down to the antenna relay to decide which antenna to go out, and then out to that antenna. If you're on bypass, it comes into the board, if you're on the bypass, it comes into the board and does not go out to the antenna tuner, just goes directly to the antenna relay and switches to the relay, to the antenna, that you're doing. Now I'm back to the same setup. I've got my dummy load, which remember is not perfectly 1-to-1, so keep that in mind. And I've added a barrel jack on the back of the unit for the power to get 12 volts in, and I'm feeding that from the lab power supply at the moment. And then I've got my nano VNA hooked up. Right now, if we look at it, we can see that we are in the antenna 1 tuner. So if we go up and we look at my monitor, you can see I've got it on continuously scanning, sweeping. You can see it sweeping. You can see that, of course, since I'm going through the tuner to a 1-to-1 or close to 1-to-1 dummy load, it doesn't look that great, but I can show you by turning the inductor, I can tune things. I'm turning some capacitance. That's capacitance being turned. So you can see that the tuner is working in here. Now I'm going to switch to tuner on antenna 2, but I have nothing hooked there. So it's going to go nuts, which we totally expect. And then I'm going to go to antenna 1 where we are connected but bypass. We're not going to have the tuner in the way. And I think you'll agree it's substantially better. I'm not even hitting 1 point. I'm probably hitting 1. Well, here, let's see exactly. Let's find out. What am I hitting here? The worst I'm seeing is about 1.25 to right here, 1.252. I would say that's pretty good considering you do have coax going through here. You've got a bunch of connectors. I think that's phenomenally good. Now if I switch to antenna 2, again, have nothing hooked into the antenna 2, it's going to go nuts again. Let's go back to my direct through on antenna 1 and we're good. So it definitely seems to be working. Let's go ahead and let me move this dummy load. As you can see, I've moved the dummy load over to antenna 2 output of the unit. And let's come over here and you can see since I moved it to that, of course, you know, the SWR is out of sight. So let's switch this to antenna 1, bypass antenna 1, and I'm sorry. There. Yeah, okay, antenna, bypass, antenna 2. And we have basically the same thing. And if I turn the tuner, you'll see little blips of things happening. But really doesn't have much of an impact. On the other hand, if I go from antenna 2 to antenna 1 now we're going to have outrageous SWR. So I would say it's working just the way. There's antenna 2 on the tuner, so I should be able to tune it. I can. You can see inductor, here's some capacitance changing. Yep, capacitors make changes, inductors making changes. I would say we're good to go. I think we've got it. Our little board is working fantastic. I'm happy to see it working. We're ready to slap the top back on and hook it back up to the radio, and we're done. Hopefully it was an interesting video, just a little bit of information to show you how things like just cable runs and such can make such a gigantic difference on, you know, your SWR. You can see here, let me give you a look in here. Here's my wiring harness up to my switch. It's just 3 lines. It's 12 volts up to the switch and 2 wires back to trigger the relays, one for the antenna, and then these are paired together for the in and out of the antenna tuner. That's it. Hope you learned a little something. Hope you enjoyed it. Thanks for tuning in to see my latest little issue to be resolved. We'll get it all hooked up and I'll be able to use this to switch antennas now. Thanks a lot. Hope to see you in another video.